Welcome to Uncle channel. I really want to thank those that subscribe to the last episode. And if you are not yet subscribed, please do try and subscribe to have more of these videos. So back to what we have, circle geometry. In the last episode, we said we're going to look into um, looking at the area of angle D. Find angle ADC. Now the thing there is just this. The reference angle to consider is the center angle. Or let me just simply put this center letter, right, which is D. The other ones are just like a combination, like a combo to support the expression. So what we have is angle D. So angle D on this shape happens to come in this form. So angle D, three angles form angle D. Oh, we have this angle here and this edge here, right? We also have another angle here, so we have the last angle here as well, right? So let's keep start and go into the whole solution proper. So what we have now right now is, last episode we said t equals to 60 degree, right? So we're going to replace this t with 60 degree. So what we have next is that we're going to look into the theorem of angle and circumference is twice the angle at the center, right? So I'm going to put 120 here because angle at the center is twice angle at the circumference. So in the same vein, our major target is to get an angle here, and angle here, right? So what we're going to do now is, since we're dealing with angle at the center and circumference, we are going to extend a radius from this center O. They are going to break this angle A, which is 60 degree, like I said, T, angle T, into two equal parts as well. So we're going to have 30 degree here. I'm going to have 30 degree here. Why is it that we have 30 degree being divided into? Because every line, or let me just say every radius, right, which is represented by lines, happens to be equal, right, in distance and in angles, right? So what we have now, so seeing this one is a radius, this one should also a radius, so we're going to have 30 here too. Degree here too, right? So we are moving gradually. Likewise, seeing this one's also a radius, like you said, the same line all through, equal in distance and also equal in terms of angle. So we're going to have 30 here too, degree. We're going to have 30 degree there too. So if you look at this right now, we're having two equal angles, which are 30 degree each of them. Alright, so now in this case we have a kind of triangle called what? Isosceles triangle that says that what? These angles, isosceles triangles, a triangle rather, are the same, right? So since we have 30 and we have 30 as the base angle, so that kind of triangle is called what? Isosceles what? Triangle. Now, like I said, circle geometry involves so many theorems, right? There is circle geometry theorem itself. We also have line theorems and we also have shape theorems. So the shape we are looking into right now is the shape of what? Triangle, right? So we are closing gradually to angle D to get angle D. Now at this very, since we're having a triangle here, also triangle here, right? Looking at this triangle too, since we're having the same radius, right? There are two radii actually having equal distance. That means that, well, let us call this angle V, and also what? This angle V degree. Now since we are having angle V as the base angles, definitely we are going to look for the value for angle V. Now, this is it in circle geometry. Once you are solving circle geometry, one thing is very paramount. That is the theorems alongside with your solving. Let me show you what I mean. Now, this represents a triangle, right? That is a socially short triangle. And we need to get the sum of angles in a triangle. Normally in mathematics, we say sum of angles in the triangle equals to what? 180 degrees. So this is how it goes in circle geometry. We have 120 degree plus v degree plus v degree equals to 180 degree. So this is what I mean. So you need to put a theorem. Now what? Sum of angles written this way in a triangle also in this way equals to, okay, you can just leave it this way. Let's go this way. Sum of angles in a triangle, right? So once you have expressed your arithmetic, you need to what? Put your theorem there. If you don't put a theorem in the solvings, in circle geometry, no matter how you are getting it right, you are going to have yourself no mark. That's just what WAEC marking guide says. Alright, so let's continue and get this v. So we're gonna have 120 degree plus 2v degree equals to what? 180 degree, right? In solving arithmetically, we're gonna have 2v degree equals to 180 degree minus 120 degree. So 2v degree equals to what? Take away 120 degree from 180, what we have left is what? 60 degree. So divide both side by 2, v equals to what? 30 degree. So that means that at this point we will be having what? 30 degree. So thank God we have gotten two angles, we mean the last angle. And the last angle we are going to look at another shape entirely, right? If you look at this triangle is a triangle up here, there's a triangle down here, right? They basically combine together to form what we call rhombus, right? Rhombus. So, and in rhombus theorem, because we're having a shape, working with the shape of rhombus, so we're going to apply rhombus theorem that says opposite angles in a rhombus are equal. That means that if 120 is here, 120 is going to be here, right? So we're going to call this place to v degree. So we're going to apply the same theorems over here, right here, since the rhombus. But mind you, sometimes they may give you something like this kind of shape, right? And we may put different, or what we call different angles there. So if the angles are different, that means that what? You don't have to have what? That rhombus theorems introduced. Something else, some other theorems have to come in play with such situation. So since we're having v here, like I said, opposite angles in the rhombus are the same. If we're having 120 here, definitely going to have 30 here and 30 here. Everything will give us 60. Yes side, this side is opposite to this, so we'll have 60 here, 60 here. So working the same arithmetic, going to have it to be what? 30 as well. 30 as well. So we have gotten our three angles that sum up to form angle D. That is angle ACD. Therefore, angle ADC equals what? 30 degree plus 30 degree plus 30 degree equals to what? 90 degree. That's how I call it a day. Just subscribe to this channel, likes and share. Thank you. See you in the next episode one more time. Bye. Have a nice